Now, this question requires the understanding of radioactivity topic in chemical kinetics. If you look at the question, we are given two species A and B. Both species are emitting the alpha particles initially at the rate of 8,000 alpha particles per minute. After 20 minutes, they emit at the rate of 3,500 alpha particles per minute. We are given half-life of A as well as B. The question is asking that what is the ratio of activity of A and B in the initial mixture. That is, what do we need to find? We need to find A naught upon B naught. This is the ratio we need to find, right? Now, two things are important to notice, that all the half-life, all the radioactive reactions follow the first order kinetics. They follow the first order kinetics, right? Second thing, we know that according to the radioactivity reaction, dN by dt is equal to lambda n. What is the meaning of that thing? Now, this equation means that the rate at which disintegration of particles takes place is equal to lambda into n. N is the number of particles available at that time when we are calculating this rate, right? Since the radiative reactions follows first order kinetics, if we talk about the species A and B at T is equal to 0, their initial activity is what? 8,000 alpha particles per minute. That means at T is equal to 0, A naught plus B naught equals 8,000, right? Both A and B are emitting 8,000 alpha particles per minute. Now, at T is equal to 20, that is after 20 minutes. If you look at half-life of A, it is 10 minutes, right? And we know, according to the first order kinetics, number of half-lives is equal to, how do we calculate the number of half-lives? It is equal to total time upon T half. Therefore, for A, we have total time how much? 20 minutes upon half-life is 10 minutes. So for A, there are two half-lives, right? That means after two half-lives, we can easily find how much A is remaining. Initially, let's say we have A as A naught. After first half-life, it is remained to be A naught by 2. This is first half-life. After second half-life, we have it is A naught by 4, right? That is, the amount of A remained after 20 minutes is A naught by 4. Now, when it comes to B, the half-life of B is 500 hours, which is very large amount, which is very large number as compared to 20 minutes, right? That means even after 20 minutes, the amount of B which has undergone disintegration or which has undergone the reaction will be very much less, right? That means there is a very small change in the amount of B even after 20 minutes, right? That means at T is equal to 20 minutes, the amount of B will be approximately equal to what we have at the initial time, that is B naught, right? Now, question says at 20 minutes, the rate is 3,500 alpha particles per minute. That means 80 plus BT is equal to how much? 3,500, right? Now, this 80 at 20 minutes is how much? A naught by 4, and BT is again B naught as we discussed, which is equal to 3,500. So we have two equations now. The first equation which we have is this one, and second equation we have is this one, right? So simultaneously solving these equations, what do? 1 minus 2, we get 3 A naught by 4 equals 8,000 minus 3,500. How much we get? We get 4,500. So A naught is equal to, this is 1,500. So A naught is equal to 6,000. And B naught we get, it is 2,000. Therefore, A naught upon B naught equals 6 by 2, which is equal to 3 upon 1, right? So the answer which is correct is option D. I hope you understand this question. Stay tuned for the next question.